Okay, so let's kickstart this. We are right on time. So good evening, everybody. Good to have you with us at IPN session with Matific on the topic problem solving in maths. Not not mere words, I would say, right? So I formally welcome Jacky Herman, who's my master trainer with the Matific Global Organization, and as I said. Uh, Jacky is actually making a comeback with us, and this is her second session. She's been with us. In fact, she's the one we started this session with a couple of months ago. Obviously, as I outlined in the very beginning, that this is a IP and Matific sort of a partnership which we forged earlier during the COVID times when we realized that, okay, our educators will need more than words, if I may say, but they will need hand-holding. So having said this, we carved out a 6-session series along with Matific, and this is actually the 5th session in this sequence, which is we are primarily hosting it for school leaders from the Indian subcontinent largely, and who are people who are IPN members. It is a session which is for maths educators till the 6th grade in specific, for a very simple reason, because currently the work or the body of work which Matific has is largely up till that grade or the middle school only. Okay, but having said this, Ms. Jacky comes with a very prestigious of a teaching background, I would say a very, very distinguished career. And now she is helping Matific globally as well. So firstly, welcome Jacky, good to have you with us all over again. I know India will come back to Australia and play some cricket in the early half of next year. So, but then till that time, you are my guest, I would say. Okay.
I hope so. I love my cricket. So, in fact, as I look straight ahead out of my window where I am, I can see the Sydney Cricket Ground.
Oh, lovely, lovely, fantastic.
Very close down the road, yeah.
Okay, okay. So I will quickly, before I take you or let you start this session, I will quickly make one disclaimer because now we have majority of the members joining in. Please use the chat box only for judicious purpose. I will request, please do not put in good evening or where are you from or your introduction. We know you very well and all of you are very, very cordially welcome to this session. Okay? We will use the chat box only for pertinent questions, please. Whenever you have it or you have an observation to make, you can make it through the chat box window. At the end of the session or the last 20 minutes of our session, we will be actually having a very extensive Q&A. So please ensure that you make your questions or your notes and you have all the relevant questions for Ms. Jacky. So Jacky, over to you. I also have Ms. Rosovin, who is part of the Matific Global team. She's also with us. And I think I can also see Rajiv, who is the head of India operations, joining in us. So welcome both of you as well. Over to you, Jacky.
Thank you for your warm welcome. And thank you everybody for joining me this evening. I'm just going to get everything set up and ready to go. And I just want to say I hope you're all safe and well, because I know it's been such a dreadful year, so challenging, and I know things are very challenging for you, particularly at the moment over in India. So we're thinking of you. I mean, things are not quite ideal here either, but I know it's a real struggle over there. So we're here to help you, and I really appreciate your time this evening. So if you missed it, I'm in Sydney, in Australia, where it's just around 9:30 p.m. And some of you might have been in my session last time, so please bear with me because there's a little bit at the beginning you might have seen before, but then we're going to get into problem solving. Problem solving is a problem. A lot of teachers struggle with problem solving, with finding good resources and coming up with some challenging mathematical thinking ideas. So I'm hoping that this will help you a little bit this evening. Now, at some point, I actually do want you to solve a problem. So you might need a pencil and paper or pen and paper, have it handy, because you might be doing a little bit of thinking and problem solving yourself. So if you've got a pen and paper handy, please grab that and have it ready. All right, let's begin. I just want to go through our agenda for tonight. Talking a little bit, and this was, if you did join me last time, you would have heard a little bit of this before, but I think it bears reflecting and going over again. And maths anxiety, it's a real issue. and not just, may I say, with students, but with teachers as well. So we'll talk a little bit about maths anxiety. What is problem solving and what is mathematical reasoning? A bit of a definition there, a bit of theory. The problems that teachers are experiencing with problem solving. Then I want to get into digital resources and how they can help and how they fill that void for a lot of teachers. And this is really important for you, especially now that you're in lockdown, making connections between your digital resources and hands-on activities, including hands-on activities that you could give your students to do at home. So feasible thinking ideas are thrown in there as well, and also how to tailor these activities, especially with using a digital resource, to your local curriculum. Okay, are we ready? Let's go. We'll get straight into it. We've got a lot to get through. So I'm hoping that you can see those headings at the top there. I want you to think about, I know it's been a while since you've been in the classroom, sadly, but I want you, if you are teachers in the classroom, or perhaps you're in a leadership role, I want you to look at your students' faces. Just remember what they look like. You've got a room full of students. How do they respond and how do they react when you say this to them? Let's do maths, or it's time to do maths. You might actually want to put this in the chat box. What percentage of your students, of your class, would you say, when you say let's do maths, are happy, excited, great, love it, thumbs up, ready to go? How many react in that way? Or how many look a bit like this? They're anxious, they're sad, they roll their eyes, you know that look, not too thrilled about doing that. I'd be very curious to see what kind of responses you get, that I get from that. So what percentage would you say? Now, the reason that I bring this up is, you can tell I was a primary school teacher, so for 28 years. And in the last almost 5 years, I joined Matific almost 5 years ago, I've travelled to hundreds of schools, training them on mathematics, showing them about Matific and digital resources. And everywhere I go, it doesn't matter where it's in Australia, New Zealand, I've been to Singapore, been all over the place, they all talk about this issue of maths anxiety, and that a lot of their students don't love mathematics in the way that they would like them to. So have a think about it. Is it 50-50? What's the split? You know, have a think about that. Anyway, why? I want you to think about, why is it? What is it that's stopping students from loving mathematics? Now, as I said, I've been to hundreds of schools and I ask students and I ask teachers that question. What do you think? Done my own little survey and research project. There are really, I think, 3 reasons that are holding students back or preventing them from loving it. And the number one reason I hear from children, it's boring. And you know, that makes me quite sad because mathematics is a very broad topic. There are lots of subjects and topics within mathematics. You know, you've got all the number strands, all the measurement and mass and capacity and volume and probabilities, lots of fun. So it's sad. You would think there'd be something in there for everybody. And yet a lot of students still say maths is boring. Now, I have my own theory as to why students who say that, why they say that. I think this is one reason, the way it's presented. I think there's still a lot of worksheets happening in the classroom. I know that's the case in Australia still today. People talk about doing more hands-on activities, but teachers are so busy, it's very tempting to photocopy and do a lot of these kinds of work. Not much fun. And the same with textbooks. I can remember back to my days as a student, where a teacher would say, turn to page 37, and we'd all roll our eyes because it was pretty boring. Now, a lot of schools have done away with the textbook, but that's what they tell me. But actually what that really means is they're not using a class set of textbooks where every child has their own textbook. But what in reality is happening is the teachers still have textbooks and they photocopy them and turn them into worksheets. So there's still a lot of textbooks and worksheets going on out there. And the other thing, and I was definitely guilty of this, and I can understand why this is happening, too much teacher instruction. We talk too much. So we're often with mathematics, it's very tempting to show the method. the fastest way to get the answer. Look, this is just how you do it. Just do this and you'll get it right and you'll get the answer. And so teachers are often using instruction and talking, and that's a bit boring after a while. So we have to be careful not to do too much of that. Now, the second reason that I think a lot of children turn their nose up at mathematics is what these guys are saying: I just don't understand it. Now, the problem in your classroom, a typical classroom, you have lots of types of learners. You've got your visual learners, your auditory learners, your hands-on learners. They all learn in different ways. So the best advice I can give you is to provide a variety of ways to present a topic. So whatever your new topic is, maybe for that week, it might be division or whatever you're doing, find different ways to present it. Yes, sometimes you will be instructional, and sometimes you'll use worksheets, and sometimes you'll use digital resources, and sometimes you should use hands-on. A little bit of everything, and then hopefully you've got it all covered. You've got every type of learner covered. Just if you can see a child's blank, try a different way. Try to explain something or present it in a different way. Now, the other, number three, the reason that I think students don't love mathematics, some students don't. This poor student here, I am scared of making mistakes. And this is that anxiety, that maths anxiety that I was talking about before. I think that a lot of children are anxious about mathematics because it's so often about the score. People see maths as very black and white. You're either right with a tick or you're wrong. Especially in primary school. It's very much in primary school. Often we just keep assessing and testing and assessing and testing. And I go to schools all the time and I ask them, what resources are you using? And often the first thing they tell me about is an assessing tool. I think assessing is only a very small part of what you should be doing. Formative assessment is very important, where you are looking throughout the whole course of your lessons on a topic and how a child is progressing and what methods they're using, what strategies they're using. But summative assessments like this, that should only be occasional. So I think maybe we focus too much on the score, and maths is not black and white. It's often about the method and the journey to get to the answer. And if you think about high school mathematics, you are often rewarded for showing you're working out. So a question might have been worth 10 marks. You might have got the end answer incorrect, got it wrong, and yet you still might have scored 8 or 9 out of 10 because you did a lot of good thinking along the way. I'm concerned that in primary schools, that doesn't happen so much. We're not rewarding students just for showing their thinking. There's also a lot of parental pressure. Parents worry about, what score did you get? Did you get 9 out of 10? Why didn't you get 10 out of 10? And a lot of schools stream their mathematics classes. By that I mean they might group the children according to ability. So there might be a top group and a middle group and a bottom group, and nobody wants to be in the bottom group. And so the parents put a lot of pressure to get that score up, and all of that is creating anxiety. It's not fun. Okay, moving on. Now, can using digital resources help with maths anxiety? Well, the short answer is yes, because as you would all know, children love technology. But does it always help? Not necessarily, because it depends what you're doing on those screens. Whatever your devices are, whether they're PCs or even mobile phones, iPads, tablets, whatever you're using, if the software looks like that, that's not really going to help the maths anxiety, because that's still about a score. That's really just putting a worksheet on a screen. And the reason I'm showing you this is because, particularly during your long extended period of lockdown, your students are probably spending a lot of time on the screens, and screen time is precious. So even in 2020, there's still a lot of online resources that look like that. So just be careful which resources you're providing for your students in terms of mathematics, because that's not going to help with anxiety. All right, I want to get on to today's topic of problem solving. What is it? We're going to talk about actually what is problem solving. Here's a bit of a definition. I just liked the way that this succinctly puts it. Problem solving is a mathematical process, and it enables us to use our math skills creatively in a wide variety of situations. I really like that it says creatively, because if you think about it, the children have worked hard in their formative years to build up their skill levels in mathematics, learnt their number facts and all of that. The problem solving is the reward for that. It's the fun part where you can do creative thinking and problem solving and actually utilize those skills. So I like that it says creatively and in a wide variety of situations, because I want to talk about the topic for today is problem solving more than just words, because we're going to talk about word problems in a moment. Now, you can try to teach children strategy on how to attack a word problem or any kind of mathematical problem solving. But the issue with that is there's not really one single procedure that works all the time, because every problem is slightly different. But you can try to be a little bit consistent in the beginning with giving them strategies, but they need to be adaptable because they need to really start to get that deeper understanding of what a question requires. Now, I don't know if you're aware of Polya and his four-step approach to problem solving. George Polya was a mathematician from Hungary who actually moved over to America and worked from Stanford University. And his thoughts about mathematical teachings and problem solving are still widely used and highly regarded today. And I do like the way he simplified it. So this was Polya's four-step approach to problem solving. Number one is all in the preparation. 2, give the students some thinking time. 3, their insight. And 4, verification. In other words, the preparation is actually trying to gain an understanding. What is this problem asking me? What am I supposed to do with this problem? Number 2 is devise a plan. Now, with devising a plan, it might be a pen and paper. Children might draw a diagram, little drawings, whatever would help them to find an approach that's going to suit that problem. Insight, well, in Australia, we would say, have a go. This is where you just have a try and implement your plan and see if it works. And number 4, of course, is very important. Time to reflect and look back. Don't just hand in your paper to the teacher. Take another look. Did it work? Do you think, or do you need to tweak it in some way? All right, and what is mathematical reasoning? Here's a few little definitions here of mathematical reasoning. It's making use of all your other mathematical skills. As I said before, you can't, if a child has not been exposed to numbers and maths and they're very young, you wouldn't get straight into problem solving. You need to actually have a solid foundation and base to start with. But there's critical skills and thinking that's involved in problem solving that you can then make use of those skills. With the development of mathematical reasoning, students recognise that mathematics makes sense and can be understood. That is crucial. So I was fortunate enough a few years ago to do the Harvard Online Teaching for Understanding course. And it's all about having depth of understanding. So in mathematics, as I said before, it's very tempting. We're all time poor. We don't have enough time to teach everything we need to teach. So it's very tempting just to show students quickly the method. For example, addition, 27 plus 44. I could do vertical addition, 27 plus 44. 7 plus 4 is 11. Put the 1, carry the 1. Remember, that was the way we taught it. I didn't understand when I was in primary school that carry the 1 is really you're carrying 10. It's not 1. So I didn't have that depth of understanding. Now, the reason why students absolutely need that depth of understanding when they're young, this is a worldwide problem. There's a massive gap from primary school to high school when it comes to mathematics. Suddenly, when they're using abstract formulas and things, it becomes like a whole other topic. And if you didn't really grasp those topics fully when you're young, you're going to struggle in high school. So that depth of understanding is very important. And, you know, with mathematical reasoning, they learn how to evaluate the situation and they select problem-solving strategies. As I mentioned, we can try and teach them a few strategies, but eventually they have to actually identify that for themselves, what's logical, what system would apply to that particular problem. Mathematical reasoners are able to reflect on solutions to problems and determine whether or not they make sense. This is something I asked my students all the time when they were doing problem solving and they thought they were finished. I'd say, look at your answer. Does it look sensible? Is it a reasonable answer? If the question says, I have 3 oranges and 5 apples, how many pieces of fruit do I have? If your answer says 3,150, ding, ding, alarm bell should be ringing. That doesn't look sensible. So if you've got a mathematical reasoner in your class, one of your students, they would know whether an answer makes sense or not. All right, let's move along. So I was talking about that teaching for understanding that I did, and Jean Piaget was a psychologist from Switzerland, actually, but his focus from in the 20th century was very much about child development and cognitive thinking and how children learn. And he's also still, his philosophy is very much regarded today still in education circles very highly. There are lots of quotes from Jean Piaget. I like many of them. I've just chosen a couple. Every time we teach a child something, we keep him from inventing it himself. This comes back to too much instruction and letting children explore. Here's a little picture of Piaget there. So children need time to play and explore for themselves. Don't always show them what to do. Give them the tools, give them the resources, and let them have a play around with it. Because this other quote, play is the answer to how anything new comes about. And that's actually pretty relevant today. If you think about what's going on with COVID and our medical scientists out there all frantically trying to find a vaccine, nobody can go to them and say, you need to do this. They actually need to play around with things. They need to explore. They need to try new things. And that's how they'll invent something new. So if a child plays around and makes an error, and then they try again and get it right, they are so much more likely to retain that and remember it down the track. That making an error is not such a bad thing, because they correct it and find another way, and that's going to actually stick in their memory much better. All right, so problem solving. Now, this is the problem with problem solving, because as I said to you, I visited hundreds of schools and trained staff on mathematics and digital resources, hundreds of them in the last few years. Now, often what would happen, I'd be in a room with lots of teachers, and I would be showing them some amazing interactive digital resource activities with mathematical thinking skills involved, and somebody would always put up their hand and ask me, do you also have problem solving in that resource? And it puzzled me for a long time, because I think I just showed you amazing problem solving. Eventually, I figured out what they meant. They meant word problems. Teachers still think, if I say to a bunch of teachers, show me what you're doing for for problem solving, or prepare a problem solving lesson, so often it looks like this. Now, word problems are just a small part of problem solving. Yeah, I'm not saying don't do word problems. In fact, we're going to do one in a minute. So I hope you've got a pen and paper handy, because you're going to need it in a minute. But it's only a small part of what mathematical reasoning and thinking is all about. So, and I'm going to show you one in a minute. Here's a bit of a clue what it's all about. Let's try one. Now, you are actually, if you're willing, you're going to try and get the answer to this question that I'm about to give you, this word problem. So get a pen and paper handy and ready to go. But more important than that, more important to me than getting the answer, I want you to start thinking about what are the pros and cons of giving a word problem like this to your students. What are the good things about it? What are the not so good things about it? Are you ready? Okay, here's our word problem. Here's a clue. There's a little cricketing clue there that what the word problem is going to be about. Here we go. All right, the word problem is, it's day 4 of the test match. In the first innings, Australia scored 495 runs and India scored 350 runs. In the second innings, Australia declared for 405 runs. How many runs does India need to win? I wonder who the first person is to get the answer right. Put it in the chat box. I don't know if I can see the chat box, but let's just see who's the first person to get the answer. I'll read the question again. Australia scored 495 runs and India scored 350 runs in the first inning. In the second innings, Australia declared for 405 runs. How many runs does India need to win? That's the question. I wonder if anybody's come up with the answer yet. I'm not sure if I can. Oh, here we are. I can start to see the chat box. We're getting lots of answers of 551 or 550. A few people have put as well. Lots and lots of people coming up with 550 or 551. They're all coming through now. I can see the chat box. Okay, I'll put you out of your misery. Here we go. Firstly, before I tell you the answer, I hope you're also thinking about what are the good things about giving a word problem like that to a student, and what are the not so good things. So the good things, the pros, I think, this is my opinion, you might think something else. It's fun if you like cricket. So I can imagine that students who do like cricket would be, cricket question. Okay, so that's fun. Another positive is that it is testing some mathematical skills there. They've got to use addition, subtraction. There's more than one way, more than one method to get the answer to that question. However, there's definitely some negatives, I believe, in this as well. And I'm just looking if anybody, I can't see the chat box at the moment, has also put some negatives. Here are the negatives that I think. It's frustrating because it's fictional. I made it up. Now, if you support Indian cricket, you're probably really angry thinking, why did she make it that Australia's doing so well? Because I'm Australian and I'm the one making up the question. So I can do whatever I want is the answer. So, but I can hear if you were giving this to a group of Indian students, they might be like, oh, so that will distract them. The story is actually distracting them from the maths. And if you don't like cricket, this is boring. It's a really confusing question and not interesting at all. So it's definitely biased towards people who have cricket knowledge. Did you notice there's some language in there? It would be like, what? I did this on purpose. Australia declared for 405 runs. What does declared mean? I know what it means. But there would be people out there thinking, I don't even know what that means. And that's going to really stump them. Now, the other thing with a problem with word problems is you need strong comprehension skills. And in this case, English skills. So your language skills need to be strong. And that's a shame because this is supposed to be about maths. But word problems often become more a literacy issue than a mathematical issue. And as I said, you needed cricket language. Now, one more point I wanted to make too. What was the impact when suddenly I challenged you, who's going to be the first person with the correct answer? If that was me, if I was sitting on the other side of this computer screen, I think I would have been really disappointed because I would have been happy to have a go, but suddenly making it a race, it's like, oh, why did it have to be about speed? Suddenly the anxiety in some of you might have started. It's like, oh, now I've got to do it fast. Be careful, be very careful when you add speed to an activity. If you make it a race, it's fine if the children have really strong skills in whatever it is you're teaching at that time. But if there are some weaker students, you have just given them a great big ball of anxiety in their stomach, making it about speed. So it did change, it really mixed it up there, didn't it? It changed the whole activity by making it a bit of a race. And if you thought you had a chance of getting this correct, but you weren't going to be fast, you probably didn't even try. I reckon a lot of people had their pen ready, and as soon as I said, who's going to be the first, you probably thought, oh, I don't want to do it now because I'm not going to be thinking that fast, especially this time of night. So be careful with adding speed into the equation. Now, as I said, I don't want this to be all about word problems tonight because this whole session is about how problem solving goes beyond words. But I'll just give you a few tips. With a system, you need to initially, at least, give children a consistent method of attacking a word problem. Now, all word problems are going to look different, so they'll have to tweak it sometimes. But this is what I like to use in the classroom, and it fits in very well with George Pollier's methods as well. So this is what I used to tell my students. Circle the useful numbers, underline the important words that you need, because I always suggest that at the end of a word problem, they write their answer in a sentence. So those key words are words they might use in that sentence. So circle the numbers that are important, underline the important words, highlight the question or questions, because some word problems want you to do 2 things or find 3 things. Okay, so just highlight that, because so often, I bet you've seen this, where a child has presented you with an answer, but they haven't actually answered what they were supposed to answer. So that cricket one, they might have said, oh, Australia scored 500 runs more or whatever, and that wasn't actually what the question asked. So make sure they're answering it properly. And as I said, show they're working out, show they're thinking, reward them for that. So if you are marking their work and they didn't get the right answer, but they did some pretty nice working out, give them some points for that, give them some kind of positive feedback for that. And as I said, write the answer in full. So if you use that system, here's that word problem I just gave you. It would look a little bit like this. So I've circled the important numbers, I underlined the words that I need, and I highlighted the question. Did you notice also, I started this word problem by saying, it's day 4 of the test match. I wonder how many students would put a circle around that number 4. Do you need it? Nope. I just threw that in there to trick you. So it's additional information that you don't actually need. It doesn't matter what day of the test match it was. But be careful if you do create your own word problems, and I recommend you do. It's much more fun to give the students something that's a topic that they're interested in, maybe throw in a few names of people that they know, the principal's name or a celebrity, or to make it a little bit more interesting rather than all about the colour of the marbles in a bag or oranges and apples. Make it a bit more interesting. But don't make it a trick. Like I put that in to trick you, and that's actually not very nice. So try not to trick them too much. All right, here's the working out that I use to get the answer. The answer is not 550, because how many runs does India need to win?
1 more.
550 would have only got them a draw. They need to get 1 more than Australia scored. Now, there were a couple of ways you could work this out. I did it by adding up Australia's totals first, because I'm Australian and they're important. So I did 495 plus 405. We scored 900. India, now this is a little bit of algebra in here. 350 plus what equals 900. This is highlighting the fact that subtraction is about finding the difference, which is handy. And then don't forget to add 1. So India needs 551. I don't know who the first person was, but there were a lot of you who got that right, to defeat Australia. And of course, my favourite batsman, he would have been the top scorer, Dave Warner. He would have top scored, probably got a double century. All right, moving along. Okay, so now this is a debate that people talk about all the time. Should we be using, especially in problem solving, should we be using digital resources or should we be using hands-on? People talk about it, debate about it all the time, especially at the moment during COVID, where there's so many schools in lockdown, and are they relying too much on digital or blah, blah. Here's my answer to that. Why not both? They shouldn't be seen as 2 totally separate things. You should be able to make connections, use a digital resource, and whatever that activity is that they did, marry that up with a nice activity that is a hands-on or a worksheet or something else. Make connections. Because if you think about occupations out there that are typically hands-on, so you might think of builders, architects, nurses even, you think of them as hands-on, but they're all using technology as well. So I think it's important that children understand they're not completely separate things. You can actually connect them. So I'm going to show you and give you some tips on how to do that. Now, these examples, these little videos I'm about to show you, I'll just pause that for a moment. These are from Matific, and these are examples of some of our activities. And the main thing I want you to get out of this is how finding problem solving, rich problem solving and mathematical thinking activities for students is hard. I know, I was a teacher for 28 years. I remember it's not easy to prepare those lessons. But digital resources can really help if they're good, the good ones, not the ones that say 3+1. These interactive, and children expect a lot from technology today. If you think about the interactive games they play, PlayStation or whatever, those graphics are amazing. So if you can find really good quality digital resources, that can help you to solve your problem-solving problem, because it'll help you to guide you. And most importantly, you shouldn't just use them on their own. I'm educating teachers all the time about this. A lot of teachers who have access to even really good online resources don't use them well. They either just use them for homework and forget about them, or they use it in this way. Assign, 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 assign. They've assigned a few activities. That'll keep the children busy and that's it. And they might look at their results, or they might get a bit of data out of it. There's a lot more you can do. A digital resource, a good one, could be a really good springboard for a lesson. You can create other activities. So I'm going to show you what I'm talking about here. This is, I don't know if you've seen magic triangles before. So let's play the video. You'll get the idea. So magic triangles, a bit like doing Sudoku, really. So with this Matific one, there's always a bit of a storyline behind it. It's in a pyramid and we're trying to solve the problem. Now, the thing that I like here, it's very non-threatening, because children can manipulate those numbers, maneuver them around however they like until they find that right solution. Magic triangles are clever because it's about, well, equivalency. It's finding the balance with those numbers. So I was actually moving all of these around until they all add up to the same, and thinking, where do I need the larger numbers? Where should I put the smaller ones? And trying to get that balance. And eventually I figured out, now I need to add them all up to 15. So I need to switch around that 1 and the 7. And I think then I got it right. They all add up to 15. Now on Matific, as I said, there'll often be a little storyline woven in there. And so now they get the key to the door and it opens up, etc. So that's lots of fun for a student. It's clever with those addition skills and equivalency skills that they need to use. How could you then build on that? I'll keep the video playing again, just so you keep getting the idea of what it's all about. But these are some ideas that I thought of. So you could actually make this a hands-on activity as well. So a child could, on a big piece of cardboard, draw a triangle. Now, you might think, well, I could just photocopy and give them a triangle to use, but actually drawing the triangle themselves is a good maths activity in itself. What type of triangle do you want them to draw? What kind of triangle is that? Is it a right angle triangle? Is it an isosceles triangle? What is it? And the measurements all have, the sides have to all be the same length. So get them to draw a triangle and put the 6 points of the triangle. You're basically recreating the magic triangle, but in a hands-on way. So they've actually got that to manipulate and make numbers, little cards, cut out the cards. So this is a nice little thing they could probably do at home. I'm very conscious of suggesting activities for remote learning, and I know you would be too. It's hard to know what equipment children have at home. What do they have access to? So I try to use things that are fairly basic, you know, maybe papers, scissors, pens, pencils, you know, try to keep it simple so that hopefully everybody can do it. So I've said put a bit of sticky blue tack on the pieces of the numbers and give them some combinations that they have to try in real life. And I love it if they take photos, or even better, a video. If you're doing remote learning, get them to send those to you and you can see them in action. Now that activity could take quite a while. My suggestion is they do the digital first, because that's fun, it's non-threatening, there's no big red cross on Matific, there's not anyway. They get to try again if they make errors. So, and then they get that understanding, and then they would be able to do this. If you did this hands-on activity without doing the digital first, you could, but it's going to be challenging. They need to have that practice first, I think. But you certainly could try it, but obviously doing the digital first would help. And if they get really good at it, they could create their own. What combination, what total could you use with the different numbers, what combinations, and then give it to a friend? Obviously, that's hard while you're in lockdown, but if you're in a classroom, that's a true assessment task. That's a formative assessment task. Rather than just a test, if they can do that, give a correct total with combinations of numbers that work, they've grasped this. That's really good number skills if they can do that. By the way, on a good quality resource, you shouldn't have to make this all up yourself. So yeah, on Matific there are lesson plans with great tips and ideas on ways you can do exactly what I'm suggesting, and that is expanding on the ideas. So this video here, this is about proportional reasoning, which is something that if I said to you, now teachers, I want you to do a lesson today about proportional reasoning. I think most teachers would freak out. How do I do that? But you'll see here, it's not so hard. But this one really provides a great way, very simple way to do it. So the ladybug has to cross this little log, and the timer is timing the ladybug. The question says, how much time will it take the ladybug to cross the long log? So there's a ruler here. Now, actually on Matific, there's lots of mathematical equipment. So protractors, rulers, that kind of thing. It feels like you're very much using the real thing. So I'm measuring the long log. The short log was 2 centimeters. The long log is 4 centimeters. I know 4 is double 2. So double 8 is 16. So that's how I worked it out. But there's multiple solutions to that. There are other ways you could work it out. I could have said, well, it took 8 seconds to travel 2 centimeters. That means it's 4 seconds for every centimeter. So if I have to travel 4 centimeters, what's 4 times 4? That's 16. So that's another way you could work it out. And then children are starting to get the idea of division is the opposite of multiplication. And this is a wonderful thing. I was talking about visible thinking. When you're back in the classroom, hopefully soon, if you get to the opportunity to watch a student attempt a question like that, you can learn a lot about that student. Get them to verbalize their thinking and explain what they're doing as they answer the question. And if children can work in pairs, it's great because there are multiple solutions. So they learn off each other. They call that peer-to-peer learning, and it's so powerful. But you could try and recreate a little activity like that. If you're in the playground, or if a child could go in the backyard or out of the street, or if they need to, even in their bedroom, if they're stuck inside, ask them, how long does it take to walk a certain distance, or run if they've got space? If they don't have space, they could walk heel toe, heel toe, heel toe. And ask them to estimate it first, because estimation is a fantastic tool. Always build estimating into almost every activity you do. And it's a great way as formative assessment again. If their estimates are way out, you know that that student hasn't grasped this topic yet. And as they get more proficient, their estimates will get stronger and closer. How long would it take to run that distance or walk that distance, whatever they're doing, to do it twice? How long would it take to walk the same distance? Well, instead of running, if walking is a quarter of the speed of running. If your friend takes twice as long as you, how long will it take him to run double the distance? So you're getting the idea of proportion. So they need those number skills, but it comes back to what I said before about being creative in the way that you provide your problem solving. Okay, and that, as I said, if they got that wrong, that proportional reasoning, if you got to observe them, it might be that they just didn't know how to use a ruler. The measuring part might have stopped them. It might not be that they couldn't reason, but maybe they couldn't measure. So if you do get a chance to watch a student, it's great. Now this one is a logic riddle. So we have people at a campsite here, and they've got backpacks of different weights, and they've got to get across the river. You can only have 150 kilograms maximum in that boat. So how can we get all of the campers to the other side of the river? Bear in mind, someone's got to sail the boat. So you've always got to have at least one person in the boat. Now, I took a few goes to get this. Some of these activities are quite challenging. So a lot of people say to me with Matific, does it only go to year 6? But get your year 6 children doing activities like this. Some of them, They might be okay numerically, but are they mathematical thinkers? And this will test them out. So it did take me a few goes, but I got it. And as I said to you before, these kinds of activities well, at least on Matific, no big red cross if they get it wrong. They actually get time to try again and to persevere. Perseverance in mathematics is really important. To let children know mistakes are okay. They happen. Don't worry. Don't panic. Just try a different way. So a really good resource should allow students the time and opportunity to do that, to play around with it and try again if they get it wrong. All right, so what could you do to match that up to a hands-on activity? You can have a fake river and a boat. If your students were back at school, how much fun would it be to put them in teams? You could have a little hula hoop or something as the boat, travel across to the other side of, it might be a netball court or a cricket pitch or whatever you've got in your playground, and observe those groups. This is a great visible thinking tip. Watch them. Who's the leader in the group, the one that's got all of the ideas, and who are the children who are sitting back not really knowing what to do? You can make little signs, you know, with the different weights of the backpack. And after a while, you could swap teams around. Put a couple of leaders together and then what happens? And so on. And maybe some of the quieter ones will start to become a little bit more vocal the more proficient they become. Yeah, and sometimes the silent followers, it's not a mathematical thing, it's a personality thing. So if you aren't at school, and I know most of you are not at the moment, you could still recreate that little activity with a fake river. Just get them to get a piece of paper, colour in a blue river, have your little boats, cut out little boats, and have your little weights and try different combinations. There are definitely ways that you could turn that into a hands-on activity. I know we're running out of time, so I'm going to quickly move along because this one is pretty special. Can you notice anything a little bit different about this one? This is a brain teaser with pouring jugs. It looks like a capacity activity, but actually it's not. It's a mathematical thinking activity where we're pouring jugs. But can you see the question? It's in a different language. Just for you. So look, everyone's different when you're choosing a digital resource. Everybody's different with what their priorities are and what is it that you actually want to achieve with your digital resource. And some of the good ones, like this one here, like Matific, you can actually get them in other languages. And the benefit of that is it's removing that cultural bias. You know, we talked about that word problem. You needed to like cricket to be able to do it well. Sometimes it's just the language that's holding children back. So this is a great way to remove that barrier. So if you do have children speaking different languages in your classroom, this offers you a way to overcome that. It's a really clever activity because you can pour in different amounts and it's a lot of trial and error. This is very much inquiry-based learning. Remember Jean Piaget about allowing children the opportunity to play and explore? It's so important. And the other thing is you can kill two birds in one stone. Teach maths and a language at the same time by changing the language. And same deal here with your visible thinking tip. Ask the student, what's your plan? Here, I'm trying to get 1 litre of water into the 11-litre jug. Get the child to verbalise their thinking. I filled up the 8 and poured it into the 7 because that left me with 1 and then I poured it into the 11-litre jug. So yes, it does depend what you're after, but something that is very beneficial with online resources, it makes it a lot easier to differentiate. And also, as I said, you can get them, well, certainly with Matific anyway, you can get other languages. And you can also find, you might want it mapped to your curriculum as well. So in the case of Matific, you can see that's the Australian site there. We have all of our curriculum there, but there's the Indian version as well, because it's mapped to, I think we're up to 60 countries now, but certainly to the Indian curriculum there. Well, thank you. I think we're pretty much on time, Bravo. How did I go on time? I hope you got a little bit out of that, everybody.
Well, lovely. In fact, I would say, because mostly all of them are muted, but certainly when you look at the chat, you can get the sense of it. So fantastic, very interesting session, Jacky. Yeah.
Thank you. I can't always see the chat box, but
Okay, but if you look at now, so firstly, let me quickly give the reply to who won or who answered
there we are.
551 correctly. I think it was Hima. Hima was the fastest on I think the chat window. So Hima, congrats, well done. Not that we have any prize for you, but then very well done. Okay.
No, but you have our love and admiration.
Yes.
Well done.
Absolutely.
And good luck to India getting that 551.
Funny. Okay, so would you mind if I stop sharing your screen and put you on the main screen for Q&A?
Yeah, absolutely.
Yeah. Okay. Sure. So here we are. And I think I'll unmute Kiran. Kiran, you have a question, and after that, Mrs. Meera Mathur can ask the question. Kiran Tripathi, first your question. If you can unmute yourself, please. We have exact 10 minutes for Q&A, and we'll do a hard stop at 6 p.m. Indian Standard Time. Yeah. Kiran Tripathi, would you like to ask the question, please? Ms. Meera, I'll go to you then. Please unmute yourself and ask the question. Yeah.
Thanks, Gaurav. Thank you, Jacky. That was a very interesting session. Something you said at the beginning really set me off because it's very close to my heart. And that was when you brought in the multiple intelligences thing. Because I think we're all going digital. Online has posed certain problems. But when it comes to a child who's very linguistic, that is when the teachers get stuck. Because this phobia of mathematics, it begins pretty early. It begins around grade 5, grade 6. That's when the word problems and things start. So anything you'd like to suggest how we could tackle the spatial intelligences and the linguistic intelligences?
It's a good question. So that's why I'm recommending that you don't always resort to problem solving in words. That's just one small part of problem solving. So obviously digital resources can help if they come in other languages. That removes that issue. But even with your hands-on, try to minimize the language involved. It shouldn't necessarily be all about language. It should be more about the physical mathematics. We've got to try and remove that aspect. But you can't completely remove it because remembering we're preparing children for the real world. And there are going to be times when language is important as well, that it won't all be presented to them nice and easily like that. Another thing relating to that I didn't mention too, about word problems. Remember I mentioned about making them fun because it could be something that children can relate to, a topic that they can relate to. I might have given you this example if you were in my webinar last time, but when my son loves cricket, loves sport, and when he was very young, first year of school, I think, the teacher called me in and said, Alex is having a lot of trouble with addition. He can't add. We're doing basic addition and he can't add. And I said, yes, he can. And the teacher was very definite. No, we've done lots of activities on addition and he can't. And I said, look, I know he can. So I said, Alex, come over here. Alex, you're playing cricket. You've got 2 boundaries and a single. How many runs are you on? He said 9. I said to the teacher, he just did 4 + 4 + 1. So sometimes putting it in a context, I said, there you go, he can add. But it had to be about sport. Funnily enough, he works in that industry now, in sports. But yes, so sometimes putting it in context is really helpful. Obviously, in the real world, it's not always going to be like that. I hope that helps a little bit.
Would you like to answer? Yeah, you can unmute yourself, Ms. Meera. You can unmute yourself. Yeah.
Yes, it does. Thank you, Jacky. And maybe we can take it forward because I don't want to hog all the time of the others.
Okay. Thank you. I appreciate it.
So kind of you. So Payal, your question, please. You can unmute yourself and ask the question. And just for the benefit of all of you, if you have a question, we can have a quick show of hand virtually. Okay. And then you can pose your question. Ms. Payal Verma, if you can unmute yourself and ask the question. While you're finding it difficult, anyone who have a question, if you have, otherwise, obviously, Sanjay Pandey. Sanjay, if you can unmute yourself, please, and ask the question. I have unmuted you from my end. Yeah, Sanjay.
Good evening, sir. Good evening, sir.
Good evening.
Actually, sir, in the online classes, you know what, there are, not many students and they are not interactive enough. So how we'll get to know that, how we can work with the, the weak student who are not interactive enough until that time they will not interact us. How we'll get to know that they are understanding or not?
Sorry, Gaurav, I didn't
Jacky,
quite
just
catch
to
all of
relay
that.
that
Could you help
question
me
to
out there?
you. Yeah, just to relay that question to you, what he means, or the gist of the question is that given the online context, how does the entire interactability stuff works? Because is that the way you're putting it, Sanjay? Exactly.
Yes, sir.
Right.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
That's
So
his question.
how does the interactivity work?
Yeah, correct.
Are you meaning from a technical standpoint?
Correct. Given it is all virtual right now, how does the entire interactability element works as per him?
Okay, well,
Yeah.
I hope I understand the question correctly. So something like Matific, for example, it's software, and basically it's a website or an app. So you can go, if you're on a computer, you go to matific.com and you can use it. If you're on a tablet, you just get the Matific app downloaded, and then a child can use it that way. And often, as you saw in the little videos, there are objects that can be maneuvered around the screen. And it's very interactive in that way, and it feels very much like the real world. So there's beading activities and protractors to measure angles and that kind of. So it is highly interactive in that way.
Okay, thank you. Thank you.
Vinay Khari, Vinay, your question.
Good evening, sir. Incredible session, ma'am. Lot of learning from and a lot of takeaway from this session. My question is regarding, as initially you mentioned about the fear among the students regarding the mathematics, and what I've seen over the years that it do attach, and this persistence of that fear from childhood to even to the college level, and even if you see at whichever field we are. How to tackle that this kind of situation, this fear which has been attached to mathematical notions.
Okay, I'm sorry that it's cutting in and out just a little bit. Gaurav, can you please
Vinay, can you repeat your question once more quickly and be a little louder? Yeah.
My question is regarding the fear attached to the students, and even it do keep on continue gradually all over our life in adulthood also, and in whichever field we are. That fear do not get away.
You are saying fear of maths? Are you saying fear of maths?
Yeah, right.
So what is he trying to say, Jacky, is that you inculcate the fear about maths a little early in your academic career, and then sadly it continues with you throughout your career. So are you saying, Vinay, that how do you mitigate that fear?
How do you take away the fear?
Yes, sir.
His question is,
you want to take how to take away the fear and anxiety.
Correct.
It would be better if they didn't have it in the first place. That would be the best solution. Is if they're taught in a very non-threatening way from an early age, then they won't even have that fear. But if you're teaching children who are already 7, 8, 9, 10 years old and they've already got that, it is very hard to remove it. And the few suggestions: try to make it fun. I know it's not always easy, but as I said, if you're doing problem solving, make it on a topic that's interesting, presented in a fun way. Digital resources, if they're good, can definitely help, because we know children love technology. There's often a storyline and fun characters, and so technology can help if it's good. But try not to make it score focused. So as I said to you early on, mathematics doesn't have to always be tick, cross, right, wrong. It's often just about the playing around and exploring and using different strategies. It doesn't always have to be about the score. A lot of and we need to re-educate parents about that, because parents, particularly in mathematics, expect to see grades and scores all the time. We need to re-educate them there.
Vinay, the Indian version of it is not always about cracking IIT. Okay, let them enjoy maths first of all. Okay, then they'll crack it.
Yeah.
Well, the key for us as primary school educators, if they don't love maths and mathematics when they're young, there is no hope that they're going to love it when they're older.
Correct.
They need to have that grasp of it and that enjoyment and no fear when they're young to have a chance when they're older. And we know that in terms of employment and the future, we talk about STEM all the time because they are the key areas of employment in the future, and maths is the key there. You won't be a scientist or work in technology or engineering if you don't have strong mathematical skills. So it's important, our job is important when they're young.
Completely out of time. We are, as I said, I like to stick on my timelines, which is 6 sharp here. But I will quickly take 2 more questions and then we'll wind this up. And I would request these questions to be very brief. I'll go with Tanya. Tanya, you can. You've been flooding me with my private chat box, so ask your question right here.
Okay.
And then I go to Chitrakala, Ji, which will be the final question. Okay? Yeah.
Good evening, everyone. So my question, what do you suggest to keep the balance between a primary and a secondary math? Specifically, grade 6 is a very crucial area. That's the area when the students are in the fear of math. So as a grade 6 mentor, you have listed a lot of beautiful activities, but anything specific you want us to keep it in mind while teaching grade 6?
Okay, it cut out a little bit, but I can tell you were talking about grade 6 is very challenging. You're just cutting in and out a little bit for me there. Bravo, was that the gist of it, about how to help your 6 students?
What she meant was that typically what you got the question is for 6th and the junior grade, which is from primary while they're going to the middle school, right? That's what you asked Tanya, right? Tanya,
Yeah.
you there?
And yeah, I taught year 6 for the last 7 years of my teaching. So I know year 6 very well. One of the issues with year 6, and you'll probably agree with me, by the time they get to year 6, you have a very wide range of abilities. You know, they might all start almost at a level playing field when they're 5 years old, but by the time they're 11 and 12, you've got those who are anxious, way behind, and you've got those who are soaring ahead. And you need to try to cater for all of them, and that's not easy. Digital can help. It's so much easier to differentiate with a digital resource because you can group the students and assign activities according to grade level, and they don't know that you've done that. You can secretly differentiate. And also the way you group your students, there are pros and cons about, I don't know if you know the word streaming, but it's basically grouping your students according to ability. There are pros and cons about that. Often if you've got your group of high achievers together, they can feed off each other and it can work really well. But then sometimes it's nice to pair them up in different ability groups and learn off each other. So I like streaming, but not 100% of the time. I do like to see children mix with different ability levels because that's the real world. And when they're in the workforce, they're going to be dealing with people who have better knowledge than them or they're weaker than them, and they need to be able to cooperate. It's a life skill. Does that help a little bit? I know it's a challenge out there. Thank you. Thank you for your question.
Thank you. Chitrakala ji, your question, and then we wind this up.
Yeah. Hello again, Gaurav and Jacky. It was a wonderful session. Well, I'm not a mathematics person. I'm a principal. When I visit the classes, what I feel is, I don't know whether to put it this way, whether it's the teacher who creates the anxiety in the children or the parents who create the anxiety. But as you said, up to grade 4, 5, they are really cool with the subject. Once they go to 6th and above, the anxiety grows. I don't know whom to blame. I have a question which is entirely different from what we were talking. Is the anxiety observed only in the Asian countries, especially in India? Is it the same with the Australian children as well? I'm a little curious to understand this.
I just missed the last part. What were you asking? What did you want to know?
The question is the anxiety in the children about the subject mathematics. Do we find only in the Asian countries, especially in India, because math is very important, we call it? Or is it there even in your country as well?
Okay, that's a really good question too. So I'll go back to the first part of what you said about where does the anxiety come from? A range of places. It could be the parents, it could be the child themselves. Sometimes you see high achievers who are still anxious. It could be the teacher. And I come back to the very first thing you said. I'm not a maths teacher, I think you said, or I'm not a maths person.
That's always anxiety.
When you're a primary school teacher, you have to teach so many subjects. Absolutely. And it's realistically, you're not going to be great at all of them. Maybe I was, I don't know, but no, you can't, some people love maths and some people don't, and everybody has their own specialty. And I have seen it many times where the teachers are anxious about mathematics. At the end of every year, we would all discuss as a group what grade level we wanted to teach the next year. And I often heard teachers say, I'd really like to teach grade 5 or 6, but I wouldn't cope with the maths. And that was the reason they didn't teach those grades, because they were worried about year 5 and 6 maths. So if the teacher is not confident and the teacher is looking a bit frazzled, then the students are probably going to feel that way as well. Now, in terms of the importance of maths, I do see in Australia is very multicultural, and I do see there are some cultural differences between the importance of maths. But it varies. I don't like to generalize because it varies. And you'll get some cultural groups where music is very important and sport could be very important. It does vary. But, I like to think that when children are young, they should be exposed to a range. Everything's important. Everything's important. Try everything, and eventually they will specialize. They should be specializing when they're 5. But I've also, sorry, I know I talk a lot and I'm going over time, Grover, sorry. But I've done many, many hundreds of parent-teacher interviews where I've had parents sit down and say, look, I don't have a maths brain and I don't think my child does either. And that's sad because they've passed their deficiency onto that child, probably unnecessarily. But that child's grown up with that thinking, I'm probably not going to be good at maths. I probably won't be. And that's okay because my parents are not good. And that's pretty sad. And there's that notion that you either have a maths brain or you don't. But that's not true because you can learn it. It's a skill. You practice, you put in the effort, you can learn it. Thank you for your question.
Thank you.
Thank you. Thank you, Jacky, once again. And thank you everyone who had joined in. I think a wonderful question. I personally feel anxiety is universal. It is not country specific, I would say. But having said this, we Indians put, I personally feel we put usually undue pressure on everything which we try to do for that matter. So having said this, thank you very much, Jacky. Always a pleasure having you with us. And having said this, I have been getting one basic question on my chat, which is with respect to how do I get to access the Matific sort of a resource platform. So for the benefit of all of you, number one, for all IPN members and their teachers, I think we have got a 2-month sort of a subscription, which is completely free of cost for all of you. And obviously from there on, it is obviously paid, and that's something you have to explore yourself. I may not be the right person to explain about that. Okay, so thank you very much, everyone who joined in. Pleasure having you all with us. I look forward to host you very, very soon. Take care.
Thank you for organizing it, and I wish you all safe times ahead. I hope everything gets back to normal very, very soon, and then we'll be back watching the cricket very, very soon. Good luck to you all.
With the stadiums full, I would say. Yes.
Yes, I hope so.
Take care, Jacky. Have a great evening ahead. Bye-bye.
Bye-bye.
Thank you, everybody. Take care. Have a safe evening ahead of you. Bye-bye.